Drones, or unmanned aerial vehicles, are no longer a futuristic concept from science fiction. They're a fundamental and transformative part of modern warfare. These unmanned systems are basically flying robots controlled by a human operator from a safe distance, or more and more, guided by their own onboard computers. Their importance really comes from their incredible versatility. Drones can hover over a battlefield for hours, providing a constant stream of information. They can carry out precision strikes with minimal collateral damage, and they can go into environments that are just too hazardous for human soldiers, forever changing how we think about risk on the battlefield. This shift is moving warfare away from relying on expensive, crude hardware and toward these agile, precise, and expendable robotic systems. The main function that brought drones into the spotlight was surveillance and reconnaissance. Before drones, getting a clear picture of enemy positions meant sending soldiers on dangerous patrols or flying multi-million-dollar reconnaissance aircraft through contested airspace. Now, a small, relatively inexpensive drone can be launched to provide high-definition, real-time video of the battlefield. This gives commanders an unprecedented level of situational awareness. They can watch enemy movements unfold, spot vulnerabilities, and direct their forces with a precision that, honestly, was just unimaginable before. This persistent stare from above means that the modern battlefield has very few places left to hide, fundamentally changing tactical planning for both offense and defense. But it's not just about watching. Drones have become formidable weapons platforms. The idea of an armed drone really took off with platforms like the Predator and Reaper, which could not only find a target but also eliminate it with a Hellfire missile. This totally revolutionized counterterrorism operations, allowing for strikes against high-value targets in remote areas. Today, this capability has expanded dramatically. We now see kamikaze or loitering munitions like the US Switchblade, which are basically flying bombs designed to crash into their targets. These systems combine surveillance and attack into a single deadly package, giving even small infantry units the power of a miniature air force. The most profound impact of drones is their ability to take on missions that are called dull, dirty, and dangerous. The dull missions involve long hours of surveillance, a task that can really wear down human pilots. The dirty missions mean flying through areas contaminated with chemical or radiological agents, and the dangerous missions are those with a super high probability of being shot down, like flying deep into enemy air defense networks. By sending an uncrewed system, a military force can get these jobs done without risking the life of a highly trained pilot or soldier. This not only saves lives but also lets commanders be bolder in their strategies, knowing that the cost of failure is measured in equipment, not people. The ongoing war in Ukraine has become the world's most significant war lab for drone technology, accelerating an arms race in autonomous systems at a breathtaking pace. The conflict is a real-world testing ground where new drone designs, tactics, and countermeasures are developed, deployed, and refined in a matter of weeks, not years. Both Russia and Ukraine are using drones on an unprecedented scale, from tiny, commercially available quadcopters to sophisticated long-range attack systems. The lessons learned on the Ukrainian plains and in its shattered cities are not just influencing the outcome of this war, they're actively shaping the military doctrines and procurement plans of nations all around the globe. Ukraine, facing a larger adversary, has embraced drone warfare out of necessity, using technology to offset its disadvantage in manpower and traditional artillery. The country set an ambitious goal to produce 1 million first-person view drones in 2024 alone. These small, agile drones, often adapted from racing models, are piloted with a video headset, giving the operator an immersive view as they fly their payload into Russian tanks, trenches, and vehicles. In a landmark event in December 2024, Ukrainian forces reportedly conducted their first-ever assault near Lipsy, using only unmanned systems, a combination of FPV aerial drones and robotic ground vehicles, signaling a new era of combined arms operations without human soldiers on the front line. This conflict isn't just limited to the skies. Unmanned ground vehicles are also making their battlefield debut. Ukraine has deployed robotic platforms for a variety of missions, including laying mines, resupplying forward positions, and even evacuating wounded soldiers from the heat of battle. In September 2024, a Ukrainian ground robot was used in a direct assault role in the Kursk Oblast. Looking ahead, military planners expect to deploy tens of thousands of these ground drones in 2025. These developments are forcing a complete rethink of ground combat, imagining a future where robotic systems lead the charge, clearing the way for human forces or fighting entirely on their own. In response to Ukraine's innovative use of drones, Russia has ramped up its own production and development. It increased its 2024 drone production target to 1.4 million units and is rapidly iterating on its own designs, including the Lancet loitering munition and long-range Shahed drones. Both sides are caught in a relentless cycle of innovation. One side develops a new drone or tactic, and the other quickly works to create a countermeasure, which in turn prompts another innovation. This rapid evolution, fueled by the grim realities of daily combat, has made Ukraine the single most important driver of drone technology in the world today, moving concepts from the drawing board to the battlefield at an unmatched speed. The next great leap in drone warfare is, honestly, the integration of artificial intelligence, or AI, which is rapidly moving drones from being remotely controlled tools to becoming truly autonomous warfighters. Instead of a human operator guiding every move, AI-enabled drones can perform complex tasks on their own. That includes navigating tricky environments without GPS, identifying and classifying potential targets, and even making the final decision to engage a target based on pre-programmed rules. This shift toward autonomy is, well, crucial for overcoming one of the biggest vulnerabilities of drones: their reliance on a constant communication link with an operator, which can be jammed by enemy electronic warfare systems. The conflict in Ukraine is already seeing the deployment of these smarter drones. In December 2024, for instance, Germany delivered the first batch of AI-enabled HX-2 Karma UAVs to Ukrainian forces. These drones are specifically designed to be resistant to electronic jamming, capable of completing their mission with minimal human input once launched. Similarly, both sides are working feverishly to incorporate AI for terminal guidance, allowing a drone to lock onto a target and pursue it even if the operator's connection is lost. This makes the drone far more lethal and resilient, ensuring it can complete its mission in the face of sophisticated enemy defenses. One of the most disruptive aspects of the drone revolution is its economic impact, which is democratizing military power. In the past, dominating the skies required an air force of fighter jets costing tens of millions of dollars each. Today, an FPV drone costing as little as $500 can be used to destroy a multi-million-dollar main battle tank. Long-range kamikaze drones can strike strategic targets hundreds of kilometers away for a tiny fraction of the cost of a cruise missile. This dramatic cost disparity allows smaller, less wealthy nations or even non-state groups to challenge larger, technologically advanced militaries in ways that were previously impossible, effectively leveling the playing field. This new reality has spurred the growth of a new generation of defense companies focused specifically on drone technology and AI. Companies like the US-based AeroVironment, maker of the Switchblade drone, and Anduril Industries are at the forefront, rapidly developing and fielding new autonomous systems. Anduril has used Ukraine as a testing ground for its technology, and recently launched its Bolt drone lineup. Even established defense giants like Lockheed Martin are investing heavily, developing uncrewed flight capabilities for existing platforms like the Black Hawk helicopter. These companies are working directly with militaries to field technology faster than ever before, creating a dynamic new ecosystem of defense innovation. Artificial intelligence is now able to identify targets like tanks from satellite images, using neural networks that can process vast amounts of data almost instantly. This kind of capability, which was once reserved for the world's most advanced militaries, is now available to much smaller players. It's honestly changing the entire balance of power on the battlefield. The rapid proliferation of drones on the battlefield has ignited an equally rapid race to develop effective countermeasures. For every new drone capability that emerges, an opposing force is working diligently to find a way to detect, track, and destroy it. The most common methods fall under the umbrella of electronic warfare, which involves jamming the radio frequencies used to control the drone or the GPS signals it relies on for navigation. When successful, a drone can be rendered useless, forced to return to its launch point, or made to simply fall out of the sky. This electronic battle for control of the airwaves is now a constant, invisible feature of the modern war zone. Beyond jamming, militaries are deploying a range of kinetic systems designed to physically shoot drones down. These range from sophisticated air defense systems, with specialized radars, to simpler solutions like machine guns equipped with advanced optics. Some systems use nets to capture smaller drones, while others employ high-powered lasers or microwave weapons to disable their electronics. Russia, for example, is developing systems like the Donbass Dome and using neural networks to help its air defense crews detect the small, fast-moving FPV drones that plague its forces. This continuous development of counter-drone systems ensures that no single drone technology remains dominant for long. This constant back and forth between drone and counter-drone creates a relentless innovation cycle that shows no signs of slowing down. A new drone is developed to be resistant to a certain type of jamming, which then prompts the development of a more powerful or sophisticated jammer. Armies are also turning to cyber attacks, attempting to hack into an opponent's drone control systems to seize control of the drone or feed its operator false information. This cat-and-mouse game means that survival on the future battlefield will depend on the ability to adapt and field new technologies faster than the enemy, making the pace of technological change a key determinant of victory. Looking forward, the influence of drones will only continue to grow. Retired U.S. General Mark Milley predicted that within a decade or two, up to one-third of the U.S. military could be robotic, a vision that's been heavily influenced by the lessons from Ukraine. The Pentagon's Replicator initiative aims to accelerate the deployment of thousands of cheap, autonomous systems to counter potential adversaries. The future of warfare will likely involve large swarms of intelligent drones, both in the air and on the ground, working in concert with human soldiers. The challenge for militaries worldwide is no longer about whether to adopt drones, but how to master this new domain of warfare in a race that has no finish line.